Here is the device called AC generator, and this makes our powerhouses all over India. In this we have a rigid frame. I have not shown that frame here. On that frame there is a shaft. In that shaft, perpendicular to it, there is a coil. We call it rotor coil because this coil is going to rotate. This way it will rotate. So this is called rotor coil. On a frame there is a large number of turns here, and this will rotate like this. Okay. Now this is one part, and this we will call as rotor. This coil is capable of rotation. This is made, there is a winding across it with the best copper, which has got the minimum resistance, and this winding is done on a frame, and this coil, this is fitted with a shaft. When we rotate this shaft from here with help of a turbine, then this will also move. So this is this is not a part of generator, but this turbine is the one through which we are giving energy. We have to rotate it, no? So we have to give it energy, so give it energy from here. So this turbine is rotated with an energy, and that energy we get from different sources. Like in thermal plant, we make steam, and that steam runs the turbine. In hydel plant, we just throw the water, let the water, allow the water to fall on the turbine will rotate. In nuclear plants, we get the heat by the nuclear reaction, convert water into steam, that steam turns the turbine. In our car and motorcycle, the engine of motorcycle that runs this shaft, that power. Similarly, in our cycle, our muscles power that rotates this turbine. So in any case, we have to rotate the shaft so that this coil is rotated, and that energy will be converted into electrical energy. So what is a dynamo? What is an AC generator? This is a device. I should have written it in the introduction. No problem, I will write it here. Introduction. This is introduction. Second part, its components or construction, we can say, or its description. Number one, it has a rotor coil, given this. Number two, it has a stator coil. A stator coil are magnets, permanent magnets to create, and these magnets are electromagnets, because electromagnets are very strong magnets. So we have these two iron pieces. There is a winding on the iron pieces. When current flows this, then there is a strong magnetic field here. So electromagnets to create magnetic field. Across the coil. Okay, this part of it. Third part is commutator, and this ring and carbon brush system, this is known as commutator. Commute, sending one thing to other. The electrons are sent from ring to the carbon brush. So commutator, ring and carbon brush system. This is a very peculiar and very important device here. You see, there are two ends of this coil, and in the two ends EMF will be induced, EMF will be generated. Now let us suppose these are the two ends. EMF is there. I want to take this electromotive force or the current to my house. To come, so I have to take these two wires from here. When I am taking these two wires from here, oh, I take it house, my house is 15 kilometers away. Now here the coil is rotating and the coil rotates this way. Again it rotates this way. Again it rotates this way. What will happen to the two wires? So they will get strangled, and just after 2-3 rounds they will break. That means it is not possible for me to take these two wires from this to my house, because outside I will have to put it on the poles, there it is fixed. Here it is rotating. So you can't keep one end as fixed and one end rotating, it will break. So it's not possible to take the two wires from here as it is. So we have to make a system. The system is like this. This one end of the wire is terminated at one ring. And that ring, if this is the shaft here, on this shaft we put a ring. On this shaft we put a ring like this. So this ring is fitted on the shaft. Now the current comes here up to this ring, and this, there is a specialty of this ring in the fitting. This is a pure copper or a good metal ring, and the axis of this ring is the same as axis of the coil. So when the whole coil rotates like this, then this ring at the center, it appears here, and this also rotates. It also rotates, but it does not change its place because axis is same this way. Then below this we have another ring. There are two rings. One is here, one is here, but what we do, one end of the coil is connected with ring 1, the second end is connected with ring number 2. So both the terminals are here. Now rotate the coil. Now if you rotate the coil like this way, and here is the shaft is also rotating, say this way. If the shaft is rotating, then what is happening to the ring? So the answer, ring is also rotating this way. Anything broken? No. Ring can rotate very well. So here the rings are rotating like this. This is one ring, and here is the second ring. Both the rings are rotating. It has got one terminal of the coil, this has got second terminal of the coil. These are rotating like this. Now EMF is created from one end to the other end. This one, any one, become positive, this becomes negative. Now I have to take this positive and negative potential to my house without breaking the two wires. So I have a unique arrangement. What do? When this ring is rotating this way, I bring a carbon block, rectangular block, and with loading a spring, I press it here. Press. Here there is a spring and I press with the spring. So it just press it. Now when it rotates, it is always in contact with it. Always in contact with it this way. So what happens? If it wants to send out any electron, the electron will come here. If any electron has to go from here, it can go because they are in contact. So this part is continuously moving, this part is continuously stationary, but even then there is an exchange of electron. The electron is commuting from ring to the brush and from brush to the ring. That is why it is known as commutator. So here the electrons can commute, here the electrons are commute. The carbon brush, these are the carbon brushes. They are fixed. The rings, red rings, they are moving part. So this is a wonderful thing of commutator when we take the electrons from moving parts to the stationary part. This is third part of this system. So this is description of AC generator. Now we come to its working. Okay, we give power to turbine, the turbine rotates, and with that shaft rotates. When the shaft rotates, an EMF is generated across the two ends, so EMF is generated across the two rings. This EMF generated, or the charge collected in these positive, negative, then these charges or this potential is taken out by the carbon brush. They are always in contact, pressed by a spring, so they can't come out. They cannot by friction create a gap. So they take out current from here, and if this is positive, this is negative, the current flows like this way, and here. If this is positive, this is negative, the current will flow like this. So when it rotates, there is an EMF, and that EMF is taken out. This is working, very simple. So this is working of a dynamo, and in this it is what is happening exactly. Now what type of current produced in a dynamo, that has to be understood very clearly. This, see only this one side, and there is another side, that is this side. Once I start from here, half cycle, this is coming down. When this is coming down, I set my fingers, this is magnetic field, this is coming down. This will be the direction of the current, this will be the direction of the current. When this is coming down, what is happening to this one? This is coming up. So in this, what will be the direction of current? Answer, direction of current will be up, up. This is side A, this is side B. So current is going this, the current is going from A, this is the direction of the current, so current is coming to A and going from B, this is B. So current comes from here, here, here and goes here. Now I am taking it inside, this. After that it start going up. When this is going up, what will be the direction of current in this? Then it will be up. So, but this is always connected with this. So in this, now what will be the direction of current? Up. That is current this way. And in this, the red one, it has gone this way. So the current goes now. In this, the current is now going down. Now in this, current is going down, so this current is going down this way. So earlier here current was in this direction, now for the next half it is in this direction, and when it reaches here, again the same thing start, it goes down, it goes up. So if you see any one, once the current goes in one direction, then current goes in the other direction. One direction, other direction. And current, when it is going here, it is coming here. So this makes the cycle complete like this. So in this whole cycle, if my house is 100 km away, this makes, there is no short circuit. This 100 km and again this. So all the electrons in this 100 km, when it is going up, all move like this. And when it is coming down, all move like this. This is what's happening in the complete one, and this is alternating current. So current, why the current is changing its direction? Because this conductor, once it is cutting the magnetic field in this direction, other half it is cutting in this direction. This direction, this direction. Once it is slow, then it cuts fast, then it is moving with the same speed, but here it cannot cut the lines, here it cuts the line. So this way the current magnitude keeps on changing and the direction also keeps on changing, one direction, other direction, one direction, other direction. This is how it's working and this is how it's producing its direction. If you want, you can describe it, you can write it, that when this conductor is going back, there is one direction of current, when it is coming up, there is another direction of current. So the current is changing its direction. Now, when it is changing its direction, then what will be the direction of the current? That we can make by a graph, and that graph we will study in the next lecture. Thank you.